that we've done all of these laws of exponents, now we should take a couple of minutes and talk about what happens when you've got exponents in equations. So I'm going to use this right triangle to lead us into this idea. So to find the missing side on this right triangle, I'm going to do Pythagorean theorem. The 17 is my hypotenuse, so that will be my C. 8 and x, doesn't matter where I put them in for A and B. So as I simplify this, 8 squared is 64, 17 squared is 289, subtracting 64 from both sides, 5. And then how do we solve this for x? Hopefully you said take the square root to get rid of the square. And when you do the square root of 225, you get 15. Now at the end of this problem is where I want to interject our rules of exponents. So when we get down to this x squared equals 225, and you all said take the square root to get rid of the square, remember, square rooting something is the same as doing what exponent? A 1/2 exponent. So watch, instead of doing the square root of x squared, I'm going to do x squared to the 1/2 exponent. And whatever I do on the left, I do on the right. And we already know on the right, 225 to the 1/2 power, or the square root of 225 is 15. On the left, though, notice when I raise the 2 to 1/2, we have our power to a power rule, which says I'm supposed to multiply 2 times 1/2, which would give me 1. And x to the first is equal to 15. So when you've got an equation with exponents in it, you've got two options. Here they are at the bottom. You can either take a root on both sides to get rid of the exponent, or you can do the reciprocal exponent on both sides. Here's an equation, x to the 2/3 power minus 14 is equal to 22. Now there's no way in the world I would know this off the top of my head. So when we solve this for x, I'm just going to add 14 to both sides. Opposite of subtraction is addition. And that'll give me x to the 2/3 is equal to 36. Now here's where I've got those two options. I can either do the 2/3 root on both sides to cancel out that exponent of 2/3, or my other option for x to the 2/3 equals 36 is I can raise this 2/3 to another exponent of 3/2, the reciprocal of 2/3. That way when we multiply 2/3 times 3/2, we'll get x to the 1 equals, and then whatever I do on the left, I do on the right, whatever 36 to the 3/2 power is. Grab your calculator and let's make sure that these methods give us the same answer. So we're going to do 36 to the 3/2 power which is 216, and then my other option was to do the 2/3 root of 36. So I'm going to type in 2/3, and then we'll go and get our x root from the math section, number 5. 2/3 root of 36 is equal to 216. Both methods gives us the same answer. Here's our last equation we'll solve. So we need to get rid of the 8, we need to get rid of the 6, and then we'll be down to the base and the exponent. So let's subtract 8 from both sides. Now to get the 6 away from the base y, we're going to have to divide by 6 because it's attached by multiplication. And here's my base and my exponent equaling 12. And here's where you got your two options. You can either do the negative 7/4 root on both sides, or your other option is to do the reciprocal of negative 7/4 which would be negative 4/7. And notice when you do this method, negative 7/4 times negative 4/7 is going to be positive 28/28, which is just positive 1. And on my calculator here, you can see when I did 12 to the 4/7 and the negative 7/4 root of 12, I come out with the same answer, 0.2417. The other thing to keep in mind here, what's nice about solving equations, you've always got a way to check yourself. So if I think y is 0.2417, I can plug that back into my original equation and make sure we get 80, and I'll do it right on my calculator. At the bottom of the screen, you can see I've done 6 times my answer to the negative 7/4 power plus 8 equals 80. So our 0.2417269111 is the correct answer. It checks out.